Hello and welcome to another Out of Spec Bits video, and welcome to EVCS 2026, where we are on the ground at the Alpitronic booth with Mike, who is the head of the North American division at Alpitronic. I am so excited to get into this video. You know, our viewers more and more have been using your guys' hardware in the US as you guys have been rolling out over the last year and a little bit. Mike, I want you to start us off with where you guys are at business-wise on our shores.
Yeah, absolutely. First of all, thanks for the time, Logan. Always great to catch up with you. We opened the business for Alpitronic in the US in 2023. We moved into a building in Charlotte, North Carolina, and we spent most of 2024 setting up the business. So that's, setting up the manufacturing lines, the service, building out the teams, signing up our first customers. We started to ship units in Q3, end of Q3, early Q4 2024. And then 25 was really our first foundational year. So we can say in 25, it was a year where the service is up and running, the manufacturing is working, and really the first full year of production. So looking ahead to 26, all of the bugs are worked out, and we're open for business.
Amazing. All right, Mike, if we could start here with a full tour.
Sure.
We have some stuff that we're more familiar with over here.
Yeah.
Walk us through what we have on display.
Yeah, sure. Maybe we'll start right here is the HYC1000.
Yes.
And this is really our flagship product. That's the flagship product that's been deployed all over Europe, and it's what we've industrialized now in the US. The HYC400 has up to 400 kilowatts of power that can be distributed in increments of 50 kilowatts, so 50 kilowatts of granularity. 600 amp cables, you can have air-cooled, oil-cooled. We can paint the cabinet any color, credit card terminal, cable management system, different cable links. So that's really the flagship product, and that's what we started to deploy now in the US since Q3, Q4 of 2024. Over here we have the HYC200. More or less it's the 400 but divided by 2, so that's 2 stacks. But again, same options, oil-cooled cables, air-cooled cables, 600 amps, credit card terminal, yes, no, cable management system. So more or less identical to the 400 but in a smaller footprint.
And is this still an all-in-one?
It's still an all-in-one, exactly. So what you see is what you get. There's no external power cabinet. I would say this one initially was more used in Europe, where space is more of a consideration. Of course, here in the US, we have so much space,
Absolutely.
Right? You can put anything, but now we start to see certain segments actually showing some interest in this in the US, so we may see more and more of these start to be deployed over time.
Amazing. Yeah, I feel like, HYC400 is kind of like the one we know and love right now in the US.
Yep.
I love seeing how much customizing you can do on that unit as far as speccing cables, speccing payment, all of that kind of stuff. NACS and CCS on this one on display. And yeah, I think our viewers know this unit as being the one that works.
Yep.
If you could just kind of speak on that for a second, on your existing products that are already on the ground in the US.
Sure.
The reliability metrics and uptime.
Yeah. I think maybe just before I jump into that, you made a good point on the cable types.
Yeah.
And that's, we're really seeing that transition happening now on the ground from CCS to NACS. And I think in Q4 of last year, 18% of all non-Tesla ports deployed were NACS ports. And that's up from 5% in Q1. So you really start to see the transition to NACS happening on the ground. Now in terms of reliability, here there's no silver bullet on how to achieve a good uptime or a good what we call charging success rate. And that starts first of all from the design of the power electronics. We design the power electronics, we know exactly what's happening inside the power conversion, we have sensors and we know really what's happening there. That's super important for us. Power electronics, that's the AC-DC conversion, that's over half the value of the charger. So if you don't know what's going on inside of your power electronics, you really don't know what's going inside of the charger. I think another one is on design. So really, not only is the product designed for manufacturing, but also designed for service. So actually, when we have an issue in the field, we don't go and diagnose in the field. We connect first remotely, and we do a remote diagnosis. 1 out of 2 times we can solve problems remotely, but the other time we cannot, we send technicians into the field with the right part and with the right training to make that swap in the field. So again, we don't come to the field with a soldering iron and try and figure out. We do that remotely, so we really want to minimize downtime for our customers. And on average, 2 hours is about the intervention time for any intervention we have in the field. But then we do take back all of the sub-assemblies back to the repair center and we analyze them. Is it a bad batch of components? Is there something wrong in the manufacturing process? Whatever the problem may be. And that's really part of our quality process to deliver on that. We also have teams of engineers who do nothing but look at the fleet of chargers out in the field and look for problems. proactively. Do we have problems with firmware? Is there a problem in this grid? Is there a problem at a temperature or whatever? And they build action plans around that to make that. So there's no silver bullet really for delivering a good uptime and reliability. It's really it's a multiplication of all of those different factors together.
Yeah, I love how comprehensive you guys are about that, because as you said, you obviously want to design the hardware to work and work well over time. Yeah. But things are going to happen, and so I love that you guys are prepared in that sense, because for the user, uptime is not just if the hardware works, it's how you guys are responding to hardware potentially not working. Amazing.
Absolutely.
So I see the HYC1000 over here. Could you take me over here? Yeah.
Let's go. Yeah. So what we call the HYC1000, this is our first entry now into distributed architecture. So as we saw on the 400, that's really what we call the all-in-one. So there's no external power cabinet. You cable in the bottom, terminate, and then everything's ready to go. With the HYC1000, we've moved to distributed architecture. Now it's not going to replace the HYC400, so we're still going to have the all-in-one, but there's different use cases where the all-in-one may be appropriate or the distributed architecture appropriate.
Exactly.
So you can see now the footprint is much smaller because there's no power electronics inside of here. This is essentially more or less a dispenser.
Yes.
Okay? 600 amp cables, same options as on the other products, so you can have air-cooled cables, oil-cooled cables, credit card to terminal. The display here is a touchscreen and buttons. Our customer really like buttons. Cable management. So we've done some, design improvements, I would say. So the screen is on front. This is one of the largest feedbacks we get from our customer. Why is the screen on the side? Can be in the front, so it's on the front.
I like
that.
So
we've done that. Also NACS and CCS. And one thing I didn't mention, that's all field changeable. So it's a no regret investment. If you want to start with 2 CCS and later go to 2 NACS, or start with 1 and 1 and then go to 2 NACS, that's all done in the field. So it's really a no regret investment. So HYC1000 with the distributed architecture is really, we're starting to see sites with more and more ports. Also sites where maybe space is a constraint. So this is really serving these use cases for higher power, more ports, maybe a space constraint.
And then, so on that note, we have, kind of a satellite-based approach where the cabinet is, not right with the ports.
Right.
Walk me through the options for site layout with that, having multiple dispensers on one cabinet.
Yeah, exactly. So each power cabinet can have up to 8 ports.
Okay.
And here in this configuration, we have 2 ports. So 1 NACS and 1 CCS. So that means we could have 4 of these dispensers times 2 ports each equals 8 ports. So up to 8 ports per power cabinet.
Amazing. And I did some research prior, Mike, and I want to hear about where this could go as far as fleet charging and higher power applications.
Yeah.
You're able to do MCS on this unit, correct?
Exactly. Now this one here is the EV dispenser, but we also have the MCS dispenser, which has the MCS cable in the middle with a sidecar of CCS to manage that transition. So we're able to really, we can have one MCS with a CCS and NACS, for example. We could have only EV dispensers. The design is super flexible to allow whatever the configuration needed by our customers.
Amazing. Mike, always appreciate you coming on the channel.
Yeah.
Thank you so much for joining.
Great to see you.
And yeah, thank you, Mike.
Thanks, Logan.